Good afternoon, my friends. It's the NOLA Mathman coming again for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
after watching this video, students will be able to solve trigonometric functions of general angles. The concept we're looking at is trigonometry. The skill we're looking at is simplifying trigonometric functions of general angles. So again, with no further ado, let's get started with our math adventure. So we're looking at, we're given our coordinates, x, y, in the same order pair form, and we're given the terminal side, which contains a point, and we're going to find the exact values of the 6 trigonometric functions of theta. So what we have here, we label x and y. We have to find r, because in order to get trig, you have to have x, y, and r. So we solve r because, again, it's the hypotenuse of our vertical and horizontal sides, which are x and y. So we have a formula that says r is equal to the square root of x squared plus y squared. We substitute x and y. R is equal to 5 squared, the square root of 5 squared plus 12 squared, which is the square root of 25 plus 144, which simplifies into the square root of 169, which is equal to 13. So we now have r, we have our x and y, and now we can generate our values for the 6 trigonometric functions. So we erase that, and we will put here the r here. And so now what we want to do is write our formulas, and this will give you a chance to learn the formulas for the 6 trigonometric functions. We write down x and y here, and so we will use those 3 components in a variety of ways to get our trig functions. We'll start with sine theta. What's the formula for sine theta? Well, it will be y over r. We have both y and r. We substitute it in. It will be 12 over 13. And we've got our sine theta. Cosine theta is x over r. So we substitute that in. We have 5 over 13. And we'll be done with r. So now we want our tangent. Tangent is equal to y over x. Y is going to be 12, x is going to be 5, so tangent theta will be 12 over 5. So now we do the other 3 trig functions. They're the inverse of those. So cosecant theta is r over y. Instead of y over r, it'll be r over y, and that will give us a value of 13 over 12. The secant will be r over x, which will, when we substitute those values in, we'll have, or we can take the reciprocal of cosine theta, which is 13 over 5. And then the trigonometric function of cotangent theta, the inverse of the tangent, which is, we flip it over, we get 5 over 12. And so now we have gotten our 6 trigonometric functions using our points, and we circle the values, and we're done with our first problem. Good job. So again, the more we do this, the easier it becomes. So again, we're going to do another example like this so we can get in the habit of doing it. So now we're going to do 3. 3 has a negative value for y, so we label it. X is 8, y is negative 15. Just like we did in the first problem, we have to figure out the value of r by using the formula, the square root of x squared plus y squared. We substitute 8 for x, we substitute negative 15 for y, and we simplify. So we have 8 squared plus negative 15 squared. We will have r is equal to the square root of 64 plus 225. 64 and 225 is 289, so r is equal to the square root of 289, which is equal to 17, I believe. Yes, 17. So now we have r. We can write down our x and y, and then like we did in the first problem, we can start generating the 6 trigonometric function values. So we'll start with So we write the x and y like we did in the last problem. You want to follow the same process over and over. We'll start with sine. Sine theta is what again? Y over r, correct. We substitute those values in and we will have negative 15 over 17. That's our sine theta. Cosine theta is what? It's x over r, correct. We substitute those values, we'll have 8 over 17. Now we look for tangent. Tangent is y over x. We substitute that in, and we will have negative 15 over 8. That will be our tangent value. Now the neat thing about the trigonometric functions of 6, if you get the first 3, you just need to take the reciprocal of those to get your other values, which we will do here. So again, since we have a negative 15 divided by positive 8, the fraction will be have a sign of negative. So cosecant theta, since it's the inverse of sine theta, our value will flip over and we will get negative 17 over 15. And so for the secant theta, which is basically the reciprocal, which is r over x, our value will be 17 over 8. And then for our cotangent value, since it's the reciprocal of tangent, it will be x over y. We still want to write the formula, even though we're flipping it over. And so our answer will be negative 8 over 15. And so again, that will pop up here in a second. And so now we have our 6 trigonometric function values for this third problem. We circle all 6, and we're done with that problem. So let's see what the NOLA MATHMAN does next. So we did a problem where both x and y were positive. In this example, x and y had different signs, and so what you notice is some of the trigonometric functions with negative values as a result. So we will move those problems there out the way and proceed to another group of problems here where we're trying to find the 6 trigonometric functions of theta. So what problem do you think we're going to do next? What is the NOLA MATHMAN over there? Well, we'll go to number 8. We have negative 8, 12. We label x and y. X is negative 8, y is 12. We have to find the value of r by taking the square root of the quantity of x squared plus y squared. We substitute negative 8 for x, substitute 12 for y, and we start to simplify. R is equal to negative 8 squared, which is 64. 12 squared is 144, so we add those together. And r is equal to the square root. What does that equal? Get your calculators out and see what you get. That will get us a value of, let me see, I'm trying to do it in my head, 208. Is that what we get? Let's see what the NOLA MATHMAN came up with. So we're looking for our little calculator here. Maybe he lost track, but you can write that down. There we go, square root of 208. Now we try to find a perfect square. Since 208 is not a perfect square, that's a factor of 208. A perfect square, that's a factor of 208. In other words, you try to break 208 down into a perfect square times another factor. So what perfect square, and you try to find the biggest, because sometimes there are problems where you can do more than one perfect square. So you try to find the greatest perfect square that can be divided equally. And so in this problem, we will have 16, because 4 also goes equally into 208. And so we factor that into 16 times 13. We take the square root of 16, which will give us 4. And so r is equal to 4 times the square root of 13. So this is the first problem where our r is not an integer value. It's a radical value. So will that change the calculations of our 6 trigonometric functions? Well, we'll see. We're about to find out. So now we're at a point where we can start solving. We start with our first one like we did before, sine theta. Do you do sine theta first or cosine theta? It doesn't matter. Typically I start with sine theta. So as you can see, like we've been doing the other problems, we write down our values of x and y to go with r. And now we can start solving our 6 trigonometric functions. Sine theta is y of r. So that will give us 12 over 4 times the square root of 13. We cannot have a square root in the denominator. So this is an example of a problem we have to what we call rationalize the denominator by multiplying both the numerator and denominator by square root of 13, which gets rid of the square root of 13 in the denominator. That will get us to 4 times 13. But since 4 factors into 12, we factor it out first. And so we end up with 3 times the square root of 13 over 13. The next one, we have negative 8 over 4 times square root of 13. We can factor 4 into negative 8 and 4 into 4, which gives us 2, negative 2 over square root of 13. We rationalize the denominator by multiplying both the numerator and denominator by the square root of 13. We're left with a simplified value of a negative 2 times square root of 13 over 13. So we got y over x, y is 12, x is negative 8. We divide both by 4. Our simplified value will be negative 3 over 2. And so tangent theta is negative 3 over 2. Now, we get the reciprocal values of the first 3 trig functions. Cosecant theta is the inverse of sine. So we flip that over and we will have 4 times the square root of 13 over 13. Since the denominator, over 12. Since the denominator is already a rational number, we don't have to divide or multiply by the square root. And so we divide both by 4 and our final answer is the square root of 13 over 3. Secant theta is r over x. We flip that over. That will be 4 times the square root of 13 over negative 8. We divide both the numerator and denominator by 4. That will give us square root of 13 over negative 2, which is negative square root of 13 over 2. Simplified. Cotangent, we'll flip that over and we'll end up getting, basically it'll be negative 2 over 3. But we write the original value, negative 8 over 12, divide both by 4, and we'll end up with negative 2/3, which is the reciprocal of negative 3/2. So we have now gotten our 6 trigonometric values. When r is a square root, you do have to do a little more work to simplify your values of the 6 trigonometric functions. So that's a neat problem to do. So what's next? We're done with that. Let's see where we go next with our problems. So is everybody getting it? We're getting more confident and comfortable. So now looks like we're gonna move those problems out the way. Are we gonna do a different type of problem now? Or will we stick with those same directions? Well, no, look like we're moving these out the way. So it looks like we're gonna do a different type of trigonometric function problem here. So we're gonna move this out the way. And we're gonna do a different type of problem for our next problem. So what is the next problem? Well, we're gonna sketch each angle and find its reference angle. So again, we're dealing with theta in an XY coordinate plane. So that's why you have XY given as ordered pairs. So now we're gonna learn how to sketch an angle in the XY coordinate plane and learn to find its reference angle. So what you wanna do is you wanna label your axis. Each of the axes represent 90 degrees. So the positive X direction is 0 degrees. The positive Y direction is 90 degrees. The negative X axis is going to be 180 degrees. And the negative Y axis is 270 degrees. So if I want 135, that is exactly between 90 and 180. And so we put our terminal side at 0 and we rotate it to the angle that's created, which is 135 degrees. And so what you do is you put an arrow and then you write the angle measurement next to it. So we are done. And the theta prime is what we call a reference angle. Reference angle is the distance from the angle to the nearest x-axis. So since 180 degrees is in quadrant 2, the reference angle will be 180 degrees minus 135 degrees, which is in the case theta. So we write the formula, which is 180 degrees minus theta. Theta is 135 degrees, so we substitute that in, and our reference angle will be equal to that difference, which is 45 degrees. And so that is our final answer. So we have sketched the angle, and we also have calculated its reference angle. So that's a good skill. And you'll learn that later when you're trying to find different trig functions in the different quadrants of the X and Y coordinate plane. That's where reference angles will do you good. We'll see that later down the line. So we did our first sketch. I'm sure we can try another problem here. Let's see what we do next. So we'll move number 9 out the way. We'll go to number 11. So now we're sketching the angle that's not given in degrees, but is given in radians. So that changes the units that we're dealing with. Instead of writing and labeling our axis using degrees, we will label our axis using radian measures. So again, at the positive x degrees, that will be 0 radian. When you go to the positive y axis, that will be pi over 2 radian. Then at the negative x, that's pi. And then at the negative y-axis, that's 3 pi over 2. And then if you went back to the positive x, that would be 2 pi. So it's 2 pi around. 5 pi over 3 is in the third quadrant between 3 pi over 2 and 2 pi. It's about a third of the way, so we draw a figure. The terminal side is 0. We rotate counterclockwise to the location of 5 pi over 3. And so that's indicated there. And so we do that. Now we have to find the reference angle. Since it's in quadrant 4, we write the formula for the reference angle in terms of the radian. So I believe that formula will be 2 pi minus theta. Yes, that's what it looks like. The NOLA MATHMAN got the same thing. Theta in this problem is 5 pi over 3, so we substitute that in. We get our least common denominator, so we get the fractions the same. So 2 pi becomes 6 pi over 3. We subtract 5 pi over 3, and that answer will be pi over 3. And so that will be the reference angle for 5 pi over 3. We circle that answer. We're done. So we've done an example where you have degrees, and we've done an example that's given in radian measure, because in trig you have to be able to do both. So we're done with number 11. Let's see what we do next. So we'll get that out the way. So we're done with sketching an angle. We wanted to do an example of a degree measure and do one with a radian measure. So now we're going to find the exact value of trigonometric expressions in relation to the XY coordinate plane. I'm sure that'll be part of it. And so they give us a group of trigonometric expressions we have to find the values of. So we have, each of the, you can have any of the 6 different trigonometric expressions. So we start with number 12, which is the sine of 150 degrees. Now again, this is where we would use the whole concept of reference angles. And so the 150 degrees is in the second quadrant. So if we want the sine of 150 degrees, we have to find its reference angle. Reference angle will be equal to 180 degrees minus theta. Theta in this problem is 150 degrees. So our reference angle is equal to 30. So that means sine of 150 degrees is equal to sine of 30 degrees. Now since sine is positive in the second quadrant, the sine of that, the sine of the sine, that kind of sounds like repetitive, but the sine of sine will be positive. So we find the sine of 30, we know that's equal to 1/2. So the sine of 150 degrees will also equal 1/2. And so that is where, because basically what this teaches you is the signs between 0 and 90, we kind of memorize, or there's a table you can get for finding the sine or cosine or tangent measures for degrees like 30, 45, 60 degrees. That's important, and that's what we use as our reference. So now we're going to do number 15, tangent of negative 30 degrees. So again, we got to figure out what quadrant negative 30 degrees is in. Which quadrant do you think it is? Well, it's in the fourth quadrant because you're going in the clockwise direction. And so we have to find its reference angle. Tangent in the fourth quadrant is going to be negative because you have sine over cosine. The sine is negative, the cosine is positive. Negative over positive will be negative. So the value of tangent for negative 30 degrees will be a negative value. I can tell you that now. So our reference angle is tangent of 30 because again, you don't see it, but if you draw negative 30 out, if you go back to the positive x-axis, it'll be only 30 degrees. So we find the value of tangent of 30. So again, since it's negative in the fourth quadrant, we put the negative. And the tangent of 30 is equal to the square root of 3 over 3. And so our value for the tangent of negative 30 degrees will equal that same thing, which is negative square root of 3 over 3. And so we're done with that. And we can either circle answer. I don't know if the NOLA Mathman, but that's usually what we like to do, to circle our final answer. We'll see him doing that. Looks like, oh, there we go. Forgot the little square root thing above the 3, but you can add that later. I'm sort of sure the NOLA Mathman accidentally erased that part of the rifle. All right, so we simplified 2 trigonometric expressions so far. Let's see what we do next. So we move problems 12 through 15 out the way. Let's see if we do any other problems. Okay, yes, we're going to go on to 16 through 19. Let's try some of those problems. Now, these problems are given from a radian perspective. The first group of problems were given in terms of degrees. And as I told you earlier, you have to be able to do both, degrees and radians. So I want to do examples of both so you can get comfortable with both concepts. So we're going to do number 16. The tangent of pi over 4. Again, pi over 4 is in quadrant 1 because that is between 0 and pi over 2. It's exactly midway before that if you drew it. So the tangent of pi over 4 is equal to 1 because the sine and cosine have the same value and anything divided by itself is 1. The reference angle is theta because it's exactly in between. So we're done with that one. That was pretty easy when you have pi over 4 tangent. Since cosine and sine have the same value, it equals 1. And again, there's a table that gives you that. That's why I'm solving. So now we're going to do the cotangent of negative pi. So again, you first want to see what quadrant. Now this is not in a quadrant. This is actually on the axis. This is the negative x-axis. That's where negative pi is located, which I will write there. See, NOLA Mathman gives us that. It's on the x-axis. Now, how does that change the value? What does that do? Well, we're about to find out. So, it's not necessarily in a quadrant. Now, cotangent is cosine over sine. And the interesting thing is, sine of pi is 0 because you're not going up or down on the y-axis. So that basically will tell us that the denominator is 0. So basically the cotangent of negative pi is undefined because you cannot divide by a denominator of 0. And so the cotangent of negative pi, which is equal to the cotangent of pi, is equal to undefined. It's not defined because you cannot have 0 in the denominator. Which again, I think the NOLA Mathman is going to put up here in a few seconds because that is that's the facts. It's just undefined. And again, that's knowing the definition of cotangent is cosine over sine, and since sine is 0 at pi, negative pi, the answer has to be undefined. And so that is our final answer, which we can circle. You know, we will be in the habit of circling. Let's see if the NOLA Mathman circles the answer. Typically he does that. That's a practice to use. And so we'll see if we do another problem. Now, what the NOLA Mathman is writing out now is what I just told you. He's telling you why it's undefined. Because sine theta is 0, and you're dividing by 0. So yeah. So that is the explanation, as I said a few seconds ago. So we're done. We circle that, and we're done now with another math adventure. After this video, you should be able to simplify trigonometric functions with different angles using both degree measure and radian measure. That's what we went through. And so until we get to another math adventure, this is the NOLA Mathman signing off. Have a blessed and prosperous day. Bye-bye.